Hello, I'm Lauren Reddington, Programs Director for the American Solar Energy Society, and I'd like to thank you all for joining us for a monthly webinar series. To kick off, I would like to inform you of who ASES is and highlight some of our current events and programs. The American Solar Energy Society is a 501c3 nonprofit organization that was established in 1954 and advocates for sustainable living and 100% renewable energy by sharing information, events, and resources to cultivate community and power progress. You can join our community at any time at ases.org/join, and webinar registrants get a special 10% off discount on all ASES memberships except for life memberships by using promo code webinar. Registration is now open for our 52nd Annual National Solar Conference, Solar 2023, Transforming the Energy Landscape for All. The conference will be held in Boulder, Colorado at the University of Colorado Boulder from August 8th through 11th, 2023. Head to ases.org/conference to register, learn about the presentation tracks, and check out the visitor's guide. Our 28th Annual National Solar Tour is set for October 6th through 8th, 2023, and will feature a collection of local tours and sites with solar and sustainable technologies across the US. The sign up to host a site or local tour will open next month. ASES also invites you to participate in our online community. This is a space for our community to collaborate, share content and information, and network with each other. We have recently launched our Mentor Match program in our online community in hopes of facilitating mentor and mentee relationships to enhance personal and professional development. Be sure to hop online and start engaging at community.ases.org. Thank you for listening to these ASES updates. I want to note that this webinar will be available in a recorded format soon. I will follow up with everyone once it is available. I will ask that you submit your comments to the chat and your questions to the Q&A section. We will do our best to review and answer everything at the end of the presentation. Now I would like to introduce you to today's presenter, Debbie Coleman, Architect AIA. As a licensed architect for over 25 years, Debbie has designed hundreds of passive solar homes across the United States and Canada in many climate zones. She obtained a Bachelor of Architecture degree from the University of Arizona, wrote and published a book on passive solar design, The Sun-Inspired House, Home Designs Warmed and Brightened by the Sun. The book and her design philosophies incorporate passive solar design strategies, guidelines from home building developed by NREL, and are continuously evolving to adapt to low energy construction methods, climate changes, and housing technologies. Her work has been published in Fine, Home Building, Home Energy, Solar Today, Mother Earth News, and Home Power. Debbie serves on the board of directors for ASES, the ASES Solar Buildings Technical Division, and the ASES Steering Committee for the National Solar Tour. She's a lead GA and member of AIA. She loves the outdoors with the ever-changing skies and enjoys the challenges of bringing natural light into right-sized, practical, sun-inspired, low-energy homes. Now I will turn it over to you, Debbie.
Okay, thank you so much, Lauren, for that warm introduction, a little bit long. And thank you, Carly, for inviting me to be a part of the ASES webinar. And thank you to everybody that's sitting there in front of a computer or some electronic device today, tuning in. I'm sure there's some experts there in passive solar design, so some of you can probably chime in and help with some of the comments. Okay, so today's webinar, Passive Solar Home Design Basics. I did want to emphasize the word basics. There's so many details. Using the sun to warm and brighten homes. A little bit about me. I'm going to skip right over this because Lauren already told you tons about me. I wish I was there with you all in person right now, because then I could tweak the session towards you. But I do kind of have these polls, and as much as possible, I'd like for you to take a look at that and maybe type it into the chat box. And if we have an opportunity to adapt to one or another group, then we can do that. But anyway, what is your primary interest in passive solar? Audience poll 2, I'd like to know your experience with it, in terms of, have you designed one, have you built one, have you monitored one, etc. Always looking to network with other people that have also done a lot of passive solar home design and construction. And audience poll 3, which is really important with the design aspect, is what climate zone do you reside in terms of the International Energy Conservation Code. Zone 6, cold, zone 2, warm, hot, humid. Anyway, knowing those kind of issues affects how we design your passive solar home. Learning objectives, I'm definitely not going to read these, but if you're trying to use this session for any kind of self-reported CEUs, these are the learning objectives. And I do want to point out down at the bottom where I say the webinar assumes a basic understanding of home energy basics. The course outline today will go through some simple how-to and a little bit of inspiration, introduction to passive solar, some of the design basics, design tools, which are by other people, and then some examples. I've tried to include a lot of examples from other design professionals toward the end of the session. Up until then, a lot of the photos that you see are bits and pieces from some of the houses that I've designed. And last but not least, we will have a pretty extensive resource section. Okay, so let's just jump right in. I'm going to move rather quickly because we have a lot to cover. Some of this will be basics. I've already said it's a basic course and we're using the sun to warm and brighten homes. So we're designing for both the sun's natural light and its heat. And designing with both of those is really an art and a science. And as we all know, as ASES members, every home is a solar home. We can either use the sun's light and solar energy, or we can let it go to waste. Historically, passive solar is not new. The Native American Pueblos Indians built hundreds of structures in the south-facing cliffs of the Southwest US. In ancient Greece, there's examples with the cities backed up to the mountains with all the homes facing south to capture the winter sun. In the United States, George Keck was the first architect to pioneer passive solar house design in 1933. He built a lot of houses with a lot of glass, but they overheated, so he played around with that. But him, in relationship with the developer Howard Sloan, built some passive solar homes and learned and experimented with those. And the solar house movement started, I guess, in the 1940s, and Frank Lloyd Wright also started incorporating passive solar design around them. So passive solar equals heating by the sun. There's no active moving parts. There doesn't have to be any moving parts for passive solar to work. And it's really easy to design a home where 20% can be heated by the sun. It's a lot harder, but it can be done up to 90%. And there's some arguments that the sun can also provide 100%, which is not out of the question. Traditionally in the United States, about half of our energy consumption is for heating and cooling. Obviously, that's going to vary a lot from different parts of the country. If you're in the north, the cooling is only a small part, the heating is a huge part. If you're in the south, it's reversed. But in summary, the sun can provide between 20 to 90% of the heating, but then passive solar's sister, passive cooling, a lot of the strategies are the same. You can also passively cool a house 20 to 90%, which means you're cutting your air conditioning 20 to 90% with some of the compatible cooling strategies. So overall, I think the goal is passive survivability. That term can be attributed to building science expert Alex Wilson, who defines it as maintaining livable conditions in the event of extended loss of power or interruptions in heating fuel. you hear about the word resilient a lot. Resilient design strategies. They're climate specific, but they can include passive solar heating, passive cooling, and PV with battery backup. But in my opinion, even without PV, a building, a home specifically, should be livable for at least a few weeks without connected utilities. And by connected, I mean even connected to your battery backup if that fails. So we have the active solar, which is really easy to see. It's usually on the roof or on the ground, no doubt. That's what it is. Some people like it, some people don't. The passive features are a little more subtle. They have to do with orientation, the windows, and the overhangs. And they must be designed for initially. They're really hard to add on later. And basically, you're arranging parts that are already in a house, just in a different configuration than you may be used to. So passive solar, along with passive cooling, more insulation, less air leakage, and smaller HVAC designs, all of that combined to mean that we need less PV to power the home, to power it for its auxiliary backup heating and just to condition the home in general. There's a lot of attention that's given to all the energy that we can get from the south-facing roof. But let's not forget that the wall also faces south. And in the US, looking at this south-facing wall, you can see it receives almost the same amount of energy per square foot or per square meter as the roof does. So we have the active PV panels. I won't go over that a lot because of this ASES group, but obviously when you add the active solar to it, the house can be 100% powered by the sun, net zero energy, and all the different appliances that use the electricity. From the passive heating standpoint, it's the mechanical system. Here's the mini split heat pump. That's what we're looking to power with the PV panels from the home conditioning standpoint. Any extra solar that you generate from the PV can power the cars. The same panels that are on, well, not the same panels, but panels that are put on the roof can also heat water to go in the house, although now there's a trend more to use that PV to power your heat pump water heater. But anyway, the sun can be heated through panels on a roof. This was a passive solar hot water heater system that I had. Solar energy can cook food. You can buy an elaborate solar cooker, or you can build a simple one out of a pizza box. I kind of like this one that was integrated into the south wall of a house in the kitchen. And it can purify drinking water. So this simple system here, this is probably 2 feet by 3 feet, could probably distill about 1 gallon of water a day, which is, you know, enough for 2 people. So no need to buy bottled water. And then one of my favorites is that solar energy can dry clothes. I like it because it's so basic. Less need to run the dryer. Okay, so some of the prerequisites of passive solar house design, you don't want to just go putting the passive features on an energy inefficient building. So the same good design principles apply to a passive solar house that would to any other house. You want the well-insulated roof, walls, floors, window. You want a tight house. You want a right-sized heating and air conditioning system designed for the worst case scenario when the sun might not be out. That's a code requirement. And in terms of HERS rating, which you hear a lot about, I think aiming for around 40 is a really good goal. And then when you add your PV, it's easy to get it down to 0 to 10. If you're going to be charging your car, then you can go below 0. Thicker insulation. And not only does it keep in more heat, it keeps out more heat. So during the hot times of the year, that same insulation is working just in reverse. And beyond code minimum is a typical recommendation. A well-sealed envelope, whether it's caulking or house wraps or the combination, A well-sealed house will not only keep out the leaking hot air or cold air, it keeps out the humidity and it keeps out dust and bugs. The right sized heating and cooling system, that's essential to the comfort of your home. That is the backup to passive solar. There's going to be times of the year with these fixed systems and our huge climate change that we see from, you know, extremes of 70 degrees from one week to the next. You can't design a fixed system to meet all needs. So you do rely on your heating and cooling backup system to help you through some of those times. But a right size one is important to the comfort inside the house. You want to introduce fresh air. There's simple passive ways to do it. There's mechanical. The trend is more to add a energy recovery ventilator that takes in the fresh air and exchanges it with the heat and puts it into the house. Blower door testing to see how much of that fresh air you need is important. And let's not forget the basics. Small homes use less embodied carbon energy to build in the first place, and they're less to operate, to heat and cool. So when people say, oh, what's the most energy efficient home? I'll usually start with, well, the smallest that you can live in. So, and those compact shapes, there's less wall area, roof area, and floor area in which to lose or gain heat through. I really like a compact footprint for, say, a slightly bigger house that might have 3 bedrooms. Rather than put those 2 bedrooms up, why not put them down in the south-facing daylight basement? You won't even be able to tell that you're in a basement. And when those homes, those spaces are nestled into the earth, there's a lot less heat loss and heat gain because the below grade temperatures are much more stable at 40 to 76 than outdoor temperatures, which have a much wider temperature swing. So breaking down the 4 basics, we have orientation, the long wall facing south. We have windows, maximizing those on the south side. Overhangs to shade those south windows in summer. And then the thermal mass that's to store possible excess heat if you have more than 7% of the floor area in south glass. So you only have to do integrate these features one time in the design and construction, and then you'll take advantage of the benefits for years. I mentioned the south facing glass. It's good to know where that is, especially because if it's not facing that way, you can cause some overheating in morning or afternoon. So true north and magnetic north are not the same, which I'm sure many of you know, but there's a huge variation. If you look in the Pacific Northwest, it's going to deviate up to 18 degrees to the east. You move over here to the northeast, and it's going to deviate 18 degrees the other way. So that's 36 degrees of variation just in the United States alone. So you really need to get that right. Where is true north and therefore true south? And one of the reasons we need to do this is just to make sure that the windows are in the right place. The sun's movement, and I apologize if this is just so basic, but it's really important. So the sun does not move the same in summer as it does in winter. In summer, it has a great big arc and covers a lot of the building. In winter, it has this little bitty path. In summer, the sun is going to be almost overhead at noon. And it's going to rise in the northeast. It's going to strike the east wall, then it's going to move around to the south, where because it's so high, it's really not hitting these south walls. And then it's going to set in the northwest, where during that afternoon, it's pounding on the west wall. In winter, it's going to be lower in the sky, about 46 degrees, as it moves from the 2 tropics of the earth. And it's going to be much lower in the sky. And it's not going to cover, it's not going to hit as much of the building. It's going to rise in the southeast most of the time. It's going to be striking the south wall of the house, and very little sun is going to hit the east and west. When you're out at your site before you build, you want to pay attention to shade patterns. You don't want to place the house in a shade pattern unless it's shade to the east and west. I really like this solar pathfinder tool that I think probably most PV installers have, where you can go out any time of day and any time of the year, and you can graph your the shade patterns on the site. I think it's a really good tool to use when you're siting a house, especially if it's a small site and you're not sure how tall those trees are and what kind of shade will they provide. Building shape, that really affects the amount of south glass. So you want to think about that early on. Some building shapes allow for more south facing windows than others do. So again, the south wall receives more hours of direct sunlight in winter than the northeast wall. So looking over here at the east wall, it might get 3 hours of morning sun in the winter, 3 hours of afternoon sun, and that's going to be sun that's low and not so strong to start with. But 6 hours in the middle of the day, on average, you will have passive solar gain. So that's kind of the basics of why most of the windows should be there. You can put them on the north, and obviously I advocate for that in terms of views and just letting in the natural light, balancing light within a room, but there's not going to be any net solar gain coming from the north windows. So rules of thumb, you might say, well, how much for the different windows? And these come out of some guidelines that I'll reference earlier that came out of some NREL work. But the west glass, a maximum of 2% of the floor area, since there's so much heat that comes in the afternoon. North 4, I actually prefer a little bit less. I really like to right size, right place the windows based on the views, but a maximum of 4. And then the east also 4%. It's a little bit more forgiving because sometimes we'll design houses so that we're taking advantage of that morning east gain. So that has a little bit more flexibility with the amount of glass. And the south glass, I like to recommend you strive for at least 4% as a bare minimum. 7%, yes, that should be easy to do, and up to 10%, which can start to get a little bit challenging with your room layout, with structural issues, and obviously with overheating. But there's all kind of exceptions to this based on the views, the lot shape, homeowners' energy priorities, individual comfort, time of day for their preference of the sun. Are they morning, afternoon people, etc. So here's a south-facing window example. And again, I'm just emphasizing this is for the northern hemisphere. So if the south glass equals 4 to 7% of the floor area, that's often called sun tempering. Then you would need no additional thermal mass for that space to maintain reasonably comfortable temperatures. If you go above the 7 up to 10, you're going to start adding thermal mass. 8% I find is a really achievable number. That's a good balance between a little bit more without being excessive. It doesn't have structural issues. It's usually not too much in terms of too much sun into a room. And just to run through an example, this little 30 by 40 foot house that I drew with 7 windows that are 3 by 5. So a 3 by 5 window with a 2-inch frame would have 12.5 square feet of glass, because we're really talking about the glass area and not the window area. And if we have 7 windows, that's about 87 square feet of south glass. So divide that by 1,200, and you can see that that's 7% of the floor area is in south glass. And you can see when you look at that wall, I would say, yeah, that looks like there's a lot of windows there. And again, I've been talking about south glass. versus south windows. An important window feature is the solar heat gain coefficient. And a glass spec of, say, 0.68, which is what you see in a lot of passive solar friendly windows, will let in 68% of the sun's heat through the glass. However, that same glass, you go put it in a window frame, and the sticker that arrives at the job site with the solar heat gain coefficient is going to be much lower. You know, it's easy to think, oh my gosh, they messed up the window order. But the window is rated as a whole, meaning the average of the frame and the glass. So that number is going to be a lot lower. And that's just the way that the National Fenestration Rating Council rates the windows. So based on that number, I like to recommend you strive for a 0.37 minimum for your south-facing windows. And it's hard to find a number that's higher than 0.51 in a window overall. Another feature of the glass is its insulating value. That's also often typically referred to as a U value. That's what you'll see on the sticker. So, and they'll be the inverse, the U value will be the inverse of the R value. So 0.23 is R 4.3. So of course, a recommendation is going to be to use better triple pane if your budget allows, or either make it so it fits in your budget, because you only have a chance to do this right once, and then hopefully you won't have to replace those windows for a really long time. If you want a higher R value, you can add insulated curtains to the inside to use on cold winter nights. Some of the cellular shades will let in light, so those can even be used on cloudy but still sunny days to let in light to the house. Overhangs, we'll talk more about those with some of the sizing, but in summary, a right size one will have, in winter, all of the windows will be in sun at noon, and in summer, they'll all be in shade. And it's amazing how well a 2-foot overhang will work as a general rule for a conventional designed house. Of course, then you have the 6 inches of gutter too that I like to recommend. Here's just another example where you can see the shade line here in winter, and then you see full shade on these windows and this attached overhang in summer. SketchUp, for anybody that uses that free software, I think is really fun for overhang design. Here's an example I plugged in, 40 degrees north latitude. You can, there's a setting under tools, so I can't remember where you add it, but you add the geolocation of where you are, and then the shade patterns that you see will be the actual sun movements for that particular day. And then you can see too, as it moves from 9 a.m. to 3 p.m., the times when you really want the sun, you can watch it move across the building. You could do a little animation of it. I think it's something that clients like to see. Still talking about shading, the east and west windows, porches. If you have to have a porch, that's a great place to put it. Obviously, if you put a porch on the south side, it's going to block your solar gain, but put the front porch, the back porch, or any other kind of porch on the east and west, because it's also going to shade those windows and shade the wall. And of course, if you had trees there, that would be probably the first choice for shading, but as you know, that's not always possible. Definitely don't cut your, moving back a minute, definitely don't cut your east and west trees down any more than you have to until you've lived in the house. And I use the same thoughts too with the south ones. When in doubt, you can always take a tree down later, but for a 30 or 40 foot tall tree to go back again, I'd rather err on the cautious side. And if it's not going to hurt your house when you take it down, then leave it up for a little while. It might not provide as much shade as you think it will. This is one of my favorite shading strategies, and it has to do with the building's orientation in plan. It is amazing, and you can see this better when you model it in SketchUp, or of course any of the other more complex tools. When you orient it, just just 10 degrees to the east, you can see that south wall is going to become in shade much earlier on a summer day than if it was facing due south. And the winter heating penalties are minimum. I think the calculations show maybe 3%. So I really like doing this in warmer climates, or if a client just has a preference for more morning sun. Okay, so moving into thermal mass, let's talk about the materials and the quantity. So materials, I like to work with ones that are already going into a house. And I think the most common is a 4-inch concrete slab, whether it's the main house with one of the cold climate foundations, or whether it's a daylight basement. I really like concrete. Then you have brick, that's great for veneers on walls, stone, tile, sheetrock. All of those are going to provide thermal mass. And there's different recommendations for where the thermal mass is. This particular diagram shows that for every square foot of glass on the south, you would need 5.5 square feet of floor area directly where that sun hits. If it's elsewhere in the room where the sun is not heating, you might need 40 square feet for every square foot of glass, but at least it's in that room where the sun is coming in. For walls, about 8 square feet of wall area for every square foot of glass. So that's where the 4-inch veneer, I think, is really good. I really like 4-inch, and some of the earlier studies and resources, some people have shown that more than 4 actually might take too long for the heat to then be released. But if you have a 4-inch slab and your insulation right underneath it, that the 4 inches is a good amount. You can have an 8-inch wall as an interior wall that separates 2 rooms, and then one side gets 4-inch and the other side has the other 4-inch. Passive cooling, just going into that a little bit, operable windows on opposite sides of a room. It's amazing how that can help cool a space. And then, of course, there's the high and low windows. A lot of times I like to design in an awning window down low and then a casement window up above. With both of those open, you're creating a stack effect, so you're getting vertical airflow that helps with cooling. Not really passive, but a simple active air distribution. A lot of times I'll specify an inline fan with say a 6-inch duct that goes from the high part of a house, if it's more than 1 story, and that will duct down to the basement to help circulate the air. It can be a small inline fan. Some of the ERVs and HRVs can be run in a recirculation mode. So when you're not bringing air in from the outside, you can be circulating what's already in the house. And I like the idea of circulating it down to a mechanical room, say where there might be a air-to-air heat pump, air-to-water heat pump, so that it can also utilize that hot air. So passive solar, it's really part of the holistic design process. It's, sometimes it's easy to think, oh, it's the whole thing, but when you're dealing with a owner, there's so many other needs that they have besides the energy and the passive solar features. There's their wish list, which could entail, endless type of things. There's the siding. Where does the road come in? How does the ground slope? What's their climate like? What's their ideal floor plan function? What construction materials does the builder like to work with? Structural issues, if they're in a high wind or high seismic area. Exterior design styles, what does the client ideally want? Mechanical systems, there's a lot of preferences for those preconceived before they start talking with us or HVAC consultants. And then there's the construction cost. Actually, I probably should have put that at the top. But anyway, I guess I'm just saying all the different things you're going to evaluate. Passive solar is just one more of them. The climate specific design, I already mentioned that, but just more things to think about. You might design a house differently at one latitude or either at a different elevation above sea level for the same latitude. The wind speed and direction, especially relation to passive cooling or where not to put an outdoor living area. Are the occupants cold natured or hot natured? You know, that's actually a fairly large one. Time of day of the different spaces. Are they using certain rooms in the morning, the afternoon? Seasonal occupancies, you know, if they're living in the house full time and are there to be active people in a passive house, that's one thing. If it's just a vacation mode, then you might, you know, do some other strategies. The preferred thermostat settings. And are they willing to operate windows and curtains? Are the homeowners willing to be active people in this passive house? And I know you've all heard there's no such thing as an energy efficient home, just energy efficient occupants. Okay, well, I wish Christopher was here to do his part of the presentation, but he had other things that came up he had to do today. So I'm just going to go through some of his tools, which I've been using for about 20 years that I think are really cool, user-friendly design tools to help with passive solar and more than passive solar, other aspects of solar energy. If you go to his website, there's a variety of design tools that he has, and I'm just going to go over two very briefly: the overhang analysis and the window heat gain. That's all we have time for today. If you go to the overhang analysis, the first thing you'll see is this little graphic, and when you enter the data about your window and your overhang, this shape right here will change. So the window size will change, the overhang might become wider, higher above the window. Anyway, it's a very good graphic visualization. The inputs, you input your latitude, the time of day you want, the time of year you want to see the results, the time of day, where the window faces, the window width, the window height, the overhang width, the overhang depth, and don't forget to include the gutter if that's going to be added, and the height above the window. I think that one's really important because it's so easy to mess that up. And a lot of times that's hard to estimate until you get into the construction detailed drawings, but just pointing it out, the height of the distance really between the top of the window and the bottom of the overhang measured vertically. And then in terms of outputs, you can choose, do you want to see the part that's shaded? Do you want to see how much sun? Do you want direct sunlight only? Do you want kilowatt hours per square meter? Do you want BTUs per square foot? But the output, I really like this. Here's the times of day. Here's the months of the year. And this one, we're showing shading. We want to see the shading option. So you can see 100% June, you know, right in the middle of the day. So that's usually a minimum. And then how far out the shading went to other parts would be climate preferences, homeowner preferences. But the bottom line is the tool is it makes it really easy to see where you're getting 100% shade and where you're getting 0% shade in January, in this case, between 8 and 4. Okay, let's see, moving into his second tool, window heat gain overview. This is what you'll see when you go to this page. You can look up your latitude by your zip code. You can also pick a city, and I believe he probably has about 250, and typically each state will have 3 to 6 to choose from. So I think it's okay to do that. I don't think you need to get into the extra details. And also in terms of inputs, once you pick a city, you don't have to enter the percent of clear sky and sunshine every day. You can just forget that part. So again, if you're picking the city first, then this is going to be already entered for you. Same thing with ground surface. You know, I might pick higher if I say, oh, where's snow? Let's see how much extra we get from reflective snow. But typically from a basic design standpoint, I'm leaving those untouched. The window part, however, I think is a lot more important. And there you can pick the type of window, which is going to equate to some of the solar heat gain coefficients, or you can enter the solar heat gain coefficient yourself. And I entered, to be conservative, 0.37, which is the minimum that I like for people to use on south facing windows. And then the orientation here, if it was a little bit to the east of south, you could change it. And then your units. Then after you click OK, then this is what you see. So you can see the amount, and the lighter areas are showing higher amounts of passive solar gain during those months and that time of day. And then down here at the bottom, you can say, email me these inputs and outputs. And then from there, you can enter them into an Excel sheet and add your own other shading strategies and other things that you'd like to do. This is my favorite, and it's actually part of the overhang, but this specific link, if you want to take a screenshot or make a note of that, it's actually a different version that's harder to find on his website. But how I will use this, just to show you, I'll draw, and this is kind of at this construction drawing stage. I'm going back, I'm double checking, and I'll look at the wall detail, and this is drawn to scale. So I will scale things right off of the scale elements, right off the wall detail. And I like this part over here on the upper right, because your overhang depth, you enter that in, the spacing, the distance between the overhang and the top of the window, and then your window height. And then usually I'm looking for direct sun only from an evaluation standpoint. And, you know, I want to see the percent of sun maybe at this point rather than the percent of shade. So reverse from the other diagram that I showed, when it's in shade, you're going to see all black at 0, you know, right here during the hottest time of the year, this being May through August. And this being January up here, you're seeing right at 100%. So ideally, you know, as a rule of thumb for most houses, you'd want to see something along that lines. And there is a YouTube video where Christopher explains these tools himself, if you want to go and look at that. And in talking with him this week, he did agree to do an ASES design tool webinar in the fall. So be on the lookout for that. He's going to be tweaking and updating some of his tools. And the second tool I'll talk about using, maybe a tool that a lot of you have used, especially if you're doing PV design, and that's introducing PV watts. And the first use of using PV watts to quantify passive solar gain that I was aware of was from Mark Rosenbaum. He's a professional engineer. He's a net zero energy instructor. And it's when I took a class with him 6 or 7 years ago that I was first introduced to that. And in his course, it's a several week-long course, he showed how you could find out how much energy is in the passive solar sunshine. So I'm going to run through Mark's example rather quickly. Here's the website if you haven't been to it. So PV watts is designed to calculate how much energy a solar electric array will generate, but we're using it to calculate the solar gain. So basically you enter your zip code, click go. Click go, it's going to show you some data on where the solar resources is coming from. And really the only two things you're going to change is the tilt, because if it's a roof panel, you're going to have the roof tilt in there. But now that we're talking about south facing glass, we're going to put in a tilt of 90. And then the azimuth, in his case, this example, his house faced 13 degrees east of true south. So if it was true south, it'd be 180, but he has entered 167. And then click go, and you'll see the solar radiation that you have per month. Then you can, there's a box in there where you can export that data, and he pasted that into a simple spreadsheet that then converts the kilowatt per square meter per day into BTUs per square foot per day, which is just the more commonly used home energy data measurement. Here you can see how he's graphed it. This is before he's added the shading information. And as he points out here, that's the amount of solar gain that reaches the exterior of the glazing. In his spreadsheet, then he's entering the solar heat gain coefficient, any shading from overhangs, and any soiling on the windows. So bottom line, after he calculates all of that out, the heat pump with the coefficient of performance of 3, meaning you get 3 times energy out for every 1 in, would be 308 kilowatt hours is what the heat pump would be providing in addition if the sun was not providing it. And for his house, that's about 27% of his heating load. Here's a poster example illustrating an example of using all of this. After I took his course, I created this poster and actually presented it at one of the ASES conferences. And if anybody's interested in it, I'll be glad to send that to you just to see an example walkthrough. But as I walked through this one, it came out that on this particular conventional passive solar, I should say, house design, the sun provided about 50% of the passive solar energy. If we had thicker, more energy efficient walls, that number would immediately go up just by changing the wall value, just by increasing the wall R values. Okay, so just to briefly, we don't have very much time left, so I'm just going to, hopefully what I think of this part is the inspiring part, some examples by other designers and architects. Orlo Stitt, holistically green homes. Look for an ASES webinar later in the year where he's going to be talking about his subdivision and his home specifically. He's been designing and building passive solar homes for, I think, over 30 years. He has a really cool subdivision. It was on the National Solar Tour. And in his subdivision, the lots were arranged so every home could take advantage of south. And the detailed covenants actually address passive and active solar. There is a video, I'm not sure if this will be able to, if this link will be active in the recorded session or not, but it's a great little 4-minute video about his project. And if you visited the National Solar Tour, you might have seen that video. So the National Solar Tour, which is one of my favorite aspects of ASES, will have some passive solar examples. And this year we added a drop-down box where you could click and see which ones are passive solar, and you can look for those. So I definitely encourage all of you to either attend the solar tour, and what we're really pushing for now is to get people to sign up, host your house virtually, host it in person, or do both. Alan Spector, he's an architect, ASES member. He has a net zero energy house that I think is really cool. He had a great poster on this at ASES conference a few years ago. And on his house, the passive solar provides about 65% of the space heating requirements. There's some really nice characteristics. Mark Challam, he's also done webinars. He's an ASES member and has done some webinars. I think he did one last year on passive solar. He has some really cool Adobe homes. These are some of Mark's inside spaces. his sunrooms, I think, are some of his favorite spaces, and he definitely designs his sunrooms for both plants and people. So I guess he feels like I do, that bringing the outdoors in makes for a better connection to nature. Keith Sharp, some of you may know, he designed and built the ambient house. Last year, he did a presentation on it at Solar 2022, and I believe he'll have more results again this year. He was on the National Solar Tour last year, will be on it again, I'm sure. His simulated performance shows 100% for both passive solar heating and nighttime ventilation cooling in climate zone 6 in Colorado. And his actual performance has been just shy of 100%. So it's really, Keith could do an entire presentation on his house too. But I just wanted to illustrate it now. He doesn't have PV yet, but last year his whole house used about 4,300 kilowatt hours. Steve Cowell is a designer builder, also in Colorado, climate zone 6. He just sent these examples showing the south side full sun, full shade, some excellent thermal mass examples, some more interior and exterior of adobe homes. Here's an addition that he did, and I thought this was rather clever. It shows you can put those south windows in a bathroom. It doesn't have to always go into the main living area. New Mexico Adobe renovation. This is Andrew Stone. He was on the ASES board of directors last year, and I was able to tour his home. It was a fairly conventional home he had renovated, but he added this wonderful 2-story solar addition in the back. Did it in a very clever manner. Here's a 30-year-old home by Peter, and I won't read through all of the things he did, but basically his 30-year-old home is still performing really well using the same basics that I've covered. Of course, now, insulation levels have increased that are typically done, but here's a house 30-year-old that's still doing well. His total gas bill last year was $260. Here's one, Clifton View Homes. It won one of the Net Zero Energy or Zero Energy Ready Home Awards this past year. And I just thought it was an excellent example. If you go to this website, you can see all kind of other good examples of the Net Zero Energy Ready homes. I really like the Self-Sufficient Earthship Homes by Michael Reynolds. They're very inspiring. This one here in Antarctica shows that, yes, passive solar does work. Really nice interiors, especially in the sunroom area. Tiny Earthship Home. I thought this one was really cool. I haven't been there. I would love to visit. 560 square feet they built for under $10,000. Has some nice characteristics to it. And this was actually a clip from a previous ASES webinar that Tim did on the Good Energy House. So if you want to go back to an ASES and look at, there's a whole webinar where he talks about his house built to passive house standards. The passive solar is providing 60% of the winter heating needs with just one small mini split heat pump. What about existing homes, buying and renovating? This home here, I've wondered as I walked by it, was it an accidental passive solar home? Here it is in winter. Here you can see the winter shade line high above the windows. The tree shade doesn't quite reach there yet. I can't help but wonder, was it accidental or did somebody plan that? Okay, we're getting near to the end now. We have some book resources on both passive solar and low energy homes. We have Theory, Edward Masria book, still the theory of passive solar is still there. The rules of thumb that a lot of these I use came from these passive solar design strategies. design basics and examples. The first part of my book talks about the basics of passive solar, and then the ebook has about 150 examples of house plans in them. Low energy homes in general. Orlo Stitt, ASES member and winner of last year's Solar Buildings Award, has published this excellent holistic book. The Pretty Good House was written by some architects, builders in the Northeast, and I think it's an excellent resource on how to design and build a pretty good house. And then more recently, from the building science and HVAC side, A House Needs to Breathe, or Does It, by Allison Bales. I highly recommend this book, especially if you're interested in the mechanical aspects of homes. And the resources, I mentioned those. I moved this one up to the front because I think you would all really enjoy. If you search, I wanted to say if you wanted to Google, but if you search on the internet for passive solar design strategies and then enter your state, it might not be the city closest to you, but you're going to find some state examples, and there, if I recall, it's quite a few pages, up to 90 specific recommendations. And the overall basics are the same. I'll just tell you that in terms of rule of thumb, but you can actually do manual worksheets within those guidelines where you can enter the square footage of all your wall, floor, and roof area, and it'll tell you your heat loss and heat gain and show you how the house performs. All these other links are ones that I've mentioned throughout the webinar. So thank you for attending. I hope you enjoy creating your own sunny, happy, and comfortable homes. And I guess now is when we go to questions. I haven't left a lot of time, but there's 4 questions left. So I'll turn that over to you, Lauren, to see what you want me to answer.
Thanks so much, Debbie. So we have a question here from Richard. Would you recommend using low/high solar gain glass on the south facing of a passive solar home?
Yes, definitely use high solar heat gain coefficient glass. When you're looking at window specs, 0.68 just for the glass and a minimum of 0.37 for the window as a whole.
And are you willing to send your slides out to attendees?
Yes, I am. I don't know that it's a huge file. I don't know the best way to do that, Lauren, if that's something that that ASES would do. But yes, there's definitely a way. So if you specifically want one, put it in the chat box, and I'll make, even if I have to put it in a Dropbox and send it to you, we'll find a way to get it to you.
Perfect. Question here from Bill: is thermal mass required for passive solar for survivability when utilities are off? How to avoid large mass of Portland cement concrete with its large embodied energy?
Yes, that's a great question. And I think that's one reason I'm more leaning toward the 8% now. Ideally, you would not be adding thermal mass. Every bit of thermal mass in there would be providing another function. You know, it would be a brick wall, a stone wall, a decorative, the concrete floor, decorative concrete. But the more mass you have, the more stable your interior temperatures are going to be.
And what's your favorite tech and machinery for energy recovery ventilation with intelligent controls to avoid over ventilation heat loss?
I do not have one. And I must say, the heating and air conditioning consultant that I had has retired. I would normally defer to him to answer that question, which I know is not what you want to hear, but he would stay up on which ones were most suitable to the passive solar homes. But I can say I have become aware of some that have a recirculation mode And that has made any that have that feature become a favorite of mine.
And for us, do you know of any K-12 schools that are doing passive solar design as a class activity?
Oh, wow. I wish I did. If somebody knows, let us know. We need to have them on the National Solar Tour for sure. No, I have taught a high school class. I mean, if anybody's teaching one, email me separately and I can send you. I taught a SketchUp class and I tried to integrate solar in general in that, and I'd be glad to send you some of my teaching slides.
And take one more question throughout time. What is your favorite for variable south wall shading?
For variable south wall shading, let's say very variable, it would be a rollout exterior awning. But again, assuming you can walk out there and roll it out. And I think the only reason I wouldn't put other things in there, metal, pull down slides, I mean, shades, has to do with the cost of it. And then anything that's automated, I'm thinking of the cost and the complexity. But in terms of exterior, I think it would be a rollout awning. But it's amazing how a right design fixed awning can perform really well. So that's always really the first choice.
Awesome. Well, we'll definitely get these slides to all of the attendees. And any other unanswered questions, is that okay to send to you, Debbie? That email you have on that slide?
Yeah,
Awesome.
Within my available time, I'll be glad to answer you or point you in a direction to somebody that that could answer them. Yeah, thank you so much, Lauren, and everybody for sitting through this an hour. I'm kind of exhausted from talking. I wish we were all in a room together.
Well, thank you so much, Debbie, for your fantastic presentation, and thank you all for joining us. And I hope to see you all next month for our next webinar, and I hope you have a great rest of your day.
Thanks,
Bye.
everybody. Bye.